Everyone, welcome back to the second part of our ICO Marketplace project. In this part, we're going to focus and build our context management with all the functionality. So make sure to open your constants file and let's start writing the code in it. So first thing, we have to import the important libraries like Ether, JS, and we have to import Web3 model. Once we have these libraries, now we can come back here and we have to import our ABIs. So we can come here and we can call it, let's say, ERC20 generator, because this is the ABI we're going to use for generating our token, and we'll allow the user to generate the token. We'll have this ABI. Let's import that, and that's coming from the same directory, JSON. We got an ABI, we have to simply replicate it, and we have to get our ICO Marketplace ABI. In the last video, we have simply copied from the remix ID, and that's what we're going to import here. So ICO Marketplace, and change this to ICO Marketplace. If I come here, you can see we have this ABI, we get the ABI. Now we can come back here, and here we have to simply export the ABI. So we're going to take the ABI of ERC20 generator, and we'll already have this ERC20 generator.ABI. We have to simply replicate it, and we have to get the byte code, because that byte code we have to pass during the function call. So let's call this byte code. We got the ABI, we got the byte code. Now we have to get the address of our ICO Marketplace. So ICO Marketplace, and we already have the address. In the last video, we have imported in our .env file, and from there we're going to access. So process.env, and we'll say and next public ICO Marketplace address. That's the name we have given. Now we have to simply replicate, and we can call it ABI because we need to interact, and we're going to simply change this, remove this one, and we already have this ICO Marketplace.ABI. So we got the address, we got the ABI. These are the important things we need. Now we have to get our Pinata API key and secret key. So let's call it Pinata key, and I will come here, export Pinata API key, and we can access from our environment variable. So we'll say env next public Pinata API key, and replicate it, and we can change this to secret key. Copy, paste here, and I have to change this to comma, and do the same thing with the above one. So change this one. So we got our API key and secret key. Now we can come back here in our .env file, and you can see we are accessing this variable. So you can simply copy, and you can simply make sure you give the exact name. So copy and paste here. Same thing you can do with the address. Simply copy this one, and that's what you can simply paste. So these names are very important. Once we're done with that, now we have to do the network configuration. So we have already deployed our contract to Polygon test network, but I'm also going to configure other main network like Binance, Polygon main network, or Base. So let's configure that. So let's call this network, and we're going to have multiple networks. So I'll call it networks, and it's going to take object of networks. So this will be Polygon MOI because we are deploying to the test network, and in this we have to define all the variables. So first thing is going to be the chain ID, and this is the chain ID for Polygon MOI network. So we'll say 0x. You can give this template literal. Inside that you have to pass the chain ID. So this is the chain ID, like 8002, convert it to a string, and it's going to be a 16 bytes. This is the general convention which you have to provide, because if the user don't have this network in their MetaMask, it's going to automatically add in their wallet. So that's what we got it, chain ID. Then we have to give the chain name, and we can call it Polygon MOI. You can literally call anything whatever you want, but this is the name is going to reflect in the MetaMask. Then we can come back here and we'll call it native currency. In that we have to define 3 things: name, symbol, and decimal point. So let's define the name. It's going to be a MATI. Then we have to define the symbol. It's going to be a MATI, and we have to define the decimal point is going to be 18. Once we're done with that, now we have to define the RPC URL and the Explorer URL. So we can come back here, we'll say RPC URLs, and it can take array. So I'm going to go with this one. So let's provide this HTTP RPC MOI Polygon technology / and make sure you have to check the RPC which you want to use. So currently I'm building this project, and this particular RPC endpoint is working absolutely fine, but maybe in future it get the updated version, or you want to use a different provider. So right now we have multiple provider which provides you this RPC endpoint. So if it's create any problem, make sure to simply replace with the new RPC URL with any provider. Okay, we got the RPC. Now we have to provide this blocks explorer URL, and here we're going to provide this in an array. So http www.oclink.com, in that we can say my, and this is the exact details you have to provide no matter which network you want to configure. These are the details you have to provide. So we are done with this. Now all we have to do is to simply replicate this. So this chain ID, name, symbol, decimal point, and RPC URL, these are the things you have to change. So simply close this one, copy and paste one more time. If you want to configure different network like Polygon main network, you can do that very easily. Simply remove this one. So this time we are configuring with the main network. So all we have to do is to simply change this variable. So change the chain ID to 1, which is Polygon Mumbai main network. 137, and here I can change this Polygon mainnet, and here I can let it be like this, and have to change the RPC URL because mainnet has a different URL. So let's change this. We'll say rpc.ankr.com Polygon. So this particular website is really powerful. It's give you RPC URL for multiple blockchains. So you can simply visit this particular website, ANKR. There you will find all the details about the RPC URL. You can also change this explorer. We'll say polyscan.com. So this is we have configured for Polygon mainnet. So simply remove this one. Now we can simply copy this one and paste, and this time we're going to configure for the Binance. So say BSC, and here we have to simply replace the details. So this is going to be 56, change this to Binance, change this to SIP Binance chain, and its BNB is going to have the same decimal point, but we have to change the RPC URL. So this will be BSC, and we have to change the explorer. So it will be BS scan. So this is for the Binance. Simply close this one, and if I want to configure one more like base, I can do that very easily. So I have to change the chain ID to 8453. Chain is going to be base main, and this will be called ETH, and here I have to do the changes. So let's change this to mainnet.base.org. So I'm using multiple provider. You have to pick which one you have to use it. But at the moment I'm recording, it's working absolutely fine. So this is for the base network. So these are the 4 network I have configuring at the moment, but you can configure multiple network as per your contract where you are deploying. So right now we have this 4 network, and we are deploying our contract to Polygon MOI test network. Now we have to build couple of function which is going to trigger and is going to look for the specific network. So we can come here, let's build the functionality. We'll say const change network, and this particular function is going to trigger if the user is connected with a different network. So our contract is deployed to Polygon, and if user is connected with the Ethereum or Binance, so it's automatically going to switch the network to Polygon test network because our contract is there. So we'll say async. In that we have to simply pass the network name. Simple logic. So here we have to build the functionality. So we're going to take this try and catch. If it's anything goes wrong, we have to catch that. So we'll say error, and here we have to build the logic. So we'll say if window.ethereum is not there, then we have to simply throw an error message. We'll say error, and in that we'll say no crypto wallet found. Obviously we have to check the Ethereum object exists in the browser or not. If it not exists, then we have to throw the error message. Now we can come back here. We'll take a wait window.ethereum, and here we have to make a request, and in that we have to simply provide all the object. So first we have to provide the method. In that we can call it wallet dash add Ethereum chain, and we have to provide the params is going to array of object. So let's deconstruct that. We'll say network name, because this network name will contain the entire data, and we can call this network, and that's the only thing we have to do here. So we have to simply pass the network name. It's going to take the details and it's going to simply configure. So that's the chain network. That's the function. Now we have to call this function. So we have to build another function called handle change. So let's export that, call handle network switch, and in that we have to simply call this particular function we have built change network. So we're going to define the network. So we'll take a variable called network name, and I have deployed the contract to Polygon MOI, so I'm going to take that. So I'll say Polygon. I can come here and you can pick any network, but I have deployed my contract, so I'm going to pick the Polygon MOI. So if you have deployed to Binance or any other network, make sure to pick that relevant one. So I'm going to simply copy and that's what I'm going to simply provide here. Got it? And then we're going to simply call the function. We'll say await change network, and we're going to simply pass the network name. In this way, what will happen, this function will run and is going to simply check for the network in the MetaMask. Very simple logic, and that's what we are calling. So once we're done with the network configuration, now we can start building the actual functionality which allow us to communicate with our contract. So let's come here, let's call this export, and let's build a function which allow us to sort the address before we actually move to writing the exact functionality. So let's call this const shorten address. We're going to pass the address and it's going to short it so we can display in our component. So it's going to be address, and we have to take a template literal. In that, we have to simply pass the address, and we're going to use the slice method. So we want the 5 character from the start, and we'll get this dot dot, and we want to have the 4 character from the last. So we'll take this address dot length -4. Simple logic, simple JavaScript. So this will give the short address which we can display in our component. Now we can start working on our actual functionality. So let's call this contract, and the first function we have to build to fetch the contract. So that's going to be a reusable function. So we'll call it const fetch contract. We have to pass 3 arguments. We have to pass the address of the contract, ABI, and the signer object, the one who is interacting with our contract. So these are the 3 details we have to pass. And we're going to use our ether package. So we'll say ether new dot contract. In that, we have to simply pass all these 3 details: address, ABI, and signer. And that's our reusable function. We can easily call in any function to get the contract. Now we can come back here, and now we have to build the functionality to interact with our ICO Marketplace contract. So let's call this export const ICO Marketplace contract. It's going to be an async function because we are interacting with the contract. We can simply open this, take a try and catch if anything goes wrong, and we can simply console log out the error. And here comes the important things, and here we have to build the entire logic. So we're going to use our web3 package, web3 model package. So first we can come here, we'll take this const web3 model, and we have to call the package web3 model. We got that one. Now we have to get the connection, and which is very easy. We already have this web3 model. In that, we have to simply call this await.connect. In this way, we can get the connection, and this will allow us to interact with the wallet. So whenever the user is interacting with any network, we can easily able to get that particular wallet object, and that's what we can assign to get the signer, that who is actually interacting. So once we have the connection, we have to get the provider, which is very easy. We'll say new ether.providers. In that, we have this the method called web3 provider, in which we have to pass our connection. We got our connection. Now we can easily able to get the contract. So let's get the signer, because that's what we have to pass into our fetch function, fetch contract function. So we'll say provider.get signer. We'll have the signer. Now we can call our fetch contract function internally to return the contract. So let's call contract fetch contract, and in that we have to pass the address of our ICO contract, which we have imported above. Then we have to pass the ABI of our ICO contract, and we have to pass the signer object. So once we have this, now we can simply return the contract from this particular function. So we can call it in all the function. So this is the entire function for getting the contract of our ICO Marketplace. So here you can see we are getting the address and the ABI. Looks good. This is fine. Now we can come back here, and we can start working on our token contract. So simply copy this particular function because it's going to have the similar structure. So we'll take this token contract, and I'm going to paste it. All we have to do is to do the little bit changes in the address and the ABI. So we can come back here. We're going to have the same thing because we have to interact with the contract, and we have to change the name. So let's call this one token contract, and this particular function is going to take the address of the token. So let's call this token address. Copy that one, and that's what we have to provide here. And we have to provide the ABI, ERC20 ABI. So we already have this ABI. So like call it ERC20 generator ABI, and we're going to have the same signer. So if we come back here, this is the ABI we are getting, and this is our reusable function for getting the contract, and we have to simply return the contract so we can interact in our function. So that's the entire code we have written in our constant. So we have imported this addresses, ABIs, then Pinata key. Here we have the network configuration. Here we have the change network function, and here we have this handle switch network, short address, fetch contract, and here we have the ICO marketplace contract, and the last one is the token contract. So things are look pretty good, and now we can start working on our index page in the context management, where we're going to utilize all of this. So come back here. So first we have to import couple of things from React. So we'll say import React. In that we're going to receive couple of things. So first thing we're going to receive is use state, then we have to receive use context, then we're going to receive create context and use effect. So these are the things we are getting from React. Now we can come back here. We have to import our ether package. So we'll say ether. Then we have to import our web3 model. After that we have to import the toaster, because we have to display the notification, and it's coming from the React hot toast. After that we have to simply do the internal import, like all the functionality we have built in our context. That's all we're going to import. So let's call it internal import. Then we have to simply call it import, and it's coming from the same directory ./constants. So in that we're going to receive couple of things. Come back here, go to constants, and this is the entire ABI for ERC20 token. No, not this one. Come back here, and we have to import all of this functionality, including the addresses and the key. So we can come back here. First we're going to simply copy, and that's what we're going to import. Then we can come back here. We have to import the bytecode. Then we can come and we have to import. Let's come back here. Here we're going to take this network change, and this particular function we're going to attach in our connect wallet function. Copy and import. Come back here. Now we have to take the, let's come back here. We have to take the short address, copy, paste. Then we can need more function. So we're going to take this address as well, ICO marketplace address, copy and paste here. Come back here. We have to get the ABI as well. No, not ABI. So no, we don't need the ABI. We need the address. So we can come back here and we can take the ICO contract, simply copy and paste here, and we need the token contract as well. So these are the things we are taking, and we can take also the Pinata API key and secret key. So simply copy this one, and we have to get the secret key as well. So we can simply pass this into a component, so we can able to create our logo. So these are the things we have imported our constant file. Looks good, no issue, everything looks good. Now we can start working on our context management. So far things are good. Come back here, let's build our context. So we'll say const state context, and we're going to use this create context. In that we have to simply state this. Once we have our state context, now we have to build the provider. So we'll take this export state context provider. In that we have to pass the children. Then we have to simply return the entire models which we're going to build. So let's call this return, and we have to build the provider. So we'll take this state context provider, close this one, let's close this one, and here we have to send the value. So all the variables, all the function we're going to build, that's all we're going to pass inside the value, so it will be available in our entire context management. And here we have to say children. This is the general setup if you want to use the context management in the application. So this is the setup we have done. Now we can come back here, and now we're going to simply take couple of state variables, like for the loading, for the recalls, for the address, for the balance. So let's take that. So let's call this state variable, and first is going to be our address of the user who is connected with the application. By default it will be empty. Let's call it capital A. Then we can take the, let's call this account balance, null. Then we have to take this call loader. By default it will be false. Then we're going to take this to recall, and it will be have a, let's say, recall with a capital C and R, and by default it will be 0. So whenever there is a transaction completed successfully, we have to simply increment this, so the function will be called internally, so we don't need to reload the page every time. Then we have to take one more, is going to be called native currency. So I'm deploying to Polygon, but if you deploy to any other network, you can simply change the currency. So we'll call it MATI. So these are the state variable. Now we have to take a state variable for the component. So once the transaction will complete, we have to close the component of like create token, create ICO. So we have to close and open those components. So let's take those state variable. So we'll call this component, and we'll take this one state, say open buy token, and by default it will be false. Then we have to take another one, it will be open withdraw token, it will be false. Then we have to take the another one, open transfer token, it will be false. Then we have to take another one, it will be open token creator, it will be false. And the last one is going to be our open created ICO, it will be false. So these are the state we are taking, 5 state we are taking for our components, which we're going to use through our entire application. So we got this, we got that. Now we have to start working on the functionality. Now we can start working on our notification component. So let's say notify success, and we are using the toaster library. All we have to do is to simply pass the message. So we'll take this message, is going to be an arrow function toasted. First we are going with the success, so we have to call the success method. In this we have to pass the duration and the message. So first we have to pass the message, and second we have to pass the duration. So I'll say duration, and I have to set the timing, that how long I want to display the notification. So I will go with 2 seconds, but you can increase this number. So this will be an error, this will be error, and this is our notification. Now we can come here, and now we can start working on our functionality. So let's call this functions. First function, we have to build our check wallet connection. After that we're going to build the current wallet function. So let's call this check if wallet connected. It's going to be an async function. We'll take this try and catch, and we're going to simply console log out the error if anything goes wrong. So we'll say, let's call this console.log, and we have this error notification. I'll go and call the notification. I'll say no account found. And now we can come back here. We'll take this if window.ethereum not exist in the browser, then we have to simply throw the error message. So return, we'll say we can call it this notify error, and we can say no account found. But if it exists, then we have to make the connection. So we'll take this cons account await window.ethereum, and we're going to call this request method, and the method is going to be, let's call this eth dash accounts, because it will automatically going to check, because in MetaMask we have multiple methods, but I'm going with this eth accounts, and it is going to return the array of accounts. So we have to get the first account. So I'll take this if account.length exists, means we have an account, then we have to simply get the very first account. So we'll say set account to account 1, and here we're going to simply take this, come back here, and here we have this provider. So we can simply take this provider, because we have to check the balance of the user, and that's what we can paste here. Once we have the provider, then we have to simply get this, call it get balance, and on the provider we have the method called get balance. So we'll say provider dot get balance, and then we have to pass the account. So it's going to give us the balance, then we have to simply convert the balance, and we have to store in our state variable. So we'll take this balance, and we have the method. We'll use this ether dot utils dot format ether, and in that we have to simply pass the get balance. That's what we have here, and looks good. Then we have to simply set the balance to our state variable. Got it. And we have to simply return the account at the end, the worst account. So this is the simple function we have, which allow us to connect with the MetaMask and check and update our balance and the account address. That's what we done. We can leave it as it is, but let's write the else statement as well, so we can be on the safer side, and we can display our error message. We'll say no account found, and that looks good. Everything's good. Now we can simply copy the same function, and we have to build a function for connect wallet. So simply close this one, copy and paste here. So we can simply copy this one and paste here, and we're going to change the name to connect wallet, and we have to change the method only. So I'm going to simply change the method to eat request accounts, and I'm going to apply the same logics. The same logic I'm going to apply. Everything's good. So this function we're going to attach in the button, so user can click and they can connect. And once we get the address, once it get connected, we have to get the address and the balance. So we are done with this two function. Now we can start working on the actual function. So first we're going to build the token create function. So it's going to have two functions. Okay, it's going to have an internal function and it's going to have the main function which we're going to attach in the front end. So let's build the internal function first. So let's say call it const, we can come here, we can const dash deploy contract. The reason why I have given this dash notation because it's an internal function, and this is the architecture we follow whenever we want to build an internal function. It's going to be an async function and it's going to receive couple of parameters which I will pass later. Okay, so let's come here, let's take a try and catch, and let's console log out the entire error object. So this is what we have. Now what I'm going to do is I'm going to simply copy this architecture, copy this boilerplate and replicate couple of times, because all the function will have the same structure. All we have to do is to simply change the name and the variable. So let's paste here, and this will be our create ERC20. Close this one, copy, paste here, and this will be called get all ICO cell token, copy, paste, and this will be a single user. Simply copy, paste, and this will be our create ICO cell, copy, paste, and this will be the buy token, and we'll have the transfer token as well. So let's change this to transfer token, and we have the last one is the withdraw token. So let's call this withdraw token with a capital T. So these are the function we have to build. So these are the function we have to build. So there is a lot of work we have to do. So let's start with the very first function, which is the create ERC20, and it's going to follow the same architecture. So to create the token, we need couple of things. We need the image, we need the name, we need the supply, we need the symbol. So we're going to take that, I call it token, and this will have the data as a form of object. We'll have the image URL and account. So these are the three data we're going to pass into our function. So once we have that, now we can come back here and we can simply deconstruct the data which we have in the token. So let's call this token, and we can get the let's say name, symbol, and the supply. We got all of these three. So we got all the details about the token, name, symbol, supply. Then we can come back here, we'll call it set loader to true. Then we can say notify success, creating token. Then we can check for a condition. We have to check whether we have all of this data or not. So we'll take this name. If name is not there, if symbol is not there, and if supply is not there, then we have to throw the error message. We'll take this notify error, and then we can say data missing. Now we can take this else in that else, and now we can come back here in the constant, and we already built this particular one. So we have to simply copy this one, and that's what we have to simply paste here in the else. So we got the Web3 connection provider and the signer. All of these we got it. And now we can simply come back here, close this one, come back here, and we can call the internal function we have built, deploy contract, and in that we have to simply pass all of these three details: signer, then we have to pass the account, and we have to pass the name, symbol, and supply. So these are the 5 details we have to pass, and we have to also pass the image URL. So simply copy, and that's what we're going to receive in our internal function. So let's come back here, and here we can display the error message. So first we have to stop the loader, then we can notify the error message. We'll say sorry, something went wrong. If the transaction failed, try later. Got it? Now we can simply copy this data and we can call and build our entire function. So this is our front end function, and here we have the internal function in which we're going to receive all of this data. So it looks good to me. Now what we can do, come back here and we have to receive this data. So we got that. Now we can start coming. Now we can come here, and here we have to build the function. So first we're going to take this factory, and we're going to call this new ether contract, and in that we have to pass all of these details. So we have to pass the ABI, then the bytecode, and the signer. In this way the user can able to create their token. So we got the factory. Now we can come back here, and on that we have to simply call the deploy function. So we'll take this total supply and we have to convert that into a number. We'll say supply. We got that into a number. Now we can come back here and we can call this initial supply, that how much supply we want to provide. So we'll take this initial supply and we have to simply convert it into a contract format. So we'll take this ether utils parse unit parse ether, and in that we can simply pass the total supply and convert it to a string, and we'll call it ether. So this is our formatted supply which we go to pass inside the contract. So that looks good. Now we can come back here. We'll take this variable called let contract await factory dot deployed. In that we have to simply pass all of this detail. So we have to pass the, let's call this initial supply, then we have to pass the name, symbol, because these are the three details we have to pass into the contract. Once we pass it, it's going to call the transaction. So we have to say transaction, and I can say S. Let's call this wait contract dot deployed. It's going to return the transaction once the token will be deployed successfully. So once we have that, now we can come back here and we have to check. So now we have to check. So we'll say if contract dot address, because once the contract will deploy successfully, we will get the address. So if address exists, means the transaction is successfully completed and the user have created their token. So we have to simply update everything. So we'll take this const today, and this particular information we're going to store in the local storage. So we are getting the date when the user is creating the token, and let's format the date. So we'll take this date new date, in that we can simply pass the date and then we can simply convert it. So we'll take this created date and we'll take this date dot to local date string, in that we can take this English US. So it will give us a formatted date. So we got our date. Now we have to build the token object which we're going to store in the local storage. So we can take a variable called token, and it's going to have all the details about the token. So let's take that first account, the one who will create the token. Then we have to take the supply, we have to convert it into a string. Then we have to take the token name, then the symbol, the same details we have to pass, the token address which will come from contract dot address. Then we have to this one, then we have to take the transaction hash which is already available in the contract dot deploy transaction dot hash. That way we can able to get the transaction hash. Now we can take this created at, we already formatted the name, and now we'll take this logo which is the US image, and that's the detail we're going to store in our local storage. We got this object. Now we can come back here. We'll take a let token history. It will be an empty array. Now we can come back here, and here we have to check. So the logic we go to build is that one user can create multiple token. Okay, so first we have to check whether the token exists in the local storage or not. If it exists, then we have to get that and we have to update. Otherwise we have to simply update it straight away. So we can come back here. We'll take this. First we have to get from the local storage. We'll take this history local storage dot get item, and we have to give a key name which we're going to store the data. So we'll take this token history. This is the key name which have the data of all the token history. Once we have that, now we have to check for this history. If the history exists, means there is a token already in the local storage, then we have to get that. So we'll take this token history JSON parse, in that we can simply call this local storage get item, and we have to give the key name which is the token history. So in that way we can able to get the data from the local storage. Once we have that, we have to simply push that to the our array, this token. So first we are getting, then we are pushing our newly created token, and after that we have to simply store it. So we'll check this set item, we'll give the name token history, the key name, and then we can simply store the entire array fresh. So simple logic we have, And at the end, we can simply call this set loader to false, because we have to stop the loader, and we can display the notification, and we're going to call this recall. So we'll take this recall plus 1. So it's going to call the all the fetching function internally, so we don't need to reload the page. And at the end, we're going to simply set the open token creator to false. We have to stop the, so we have to simply close the component of token creator. So that's what we have here. Else, we can simply copy this one and we can save here. If there is no token available in the local storage, then we have to store the data straight away. So we can simply remove this one and we can simply push and store, and the rest would be fine. Looks good. And that's the only thing we have to do. Now we can come back here and we can get this notification and loader as well, and we can paste here if anything goes wrong. And we can see everything is looking good. We are getting all of this data, then we are getting the factory contract, then we are converting that into a contract format, the supply, and we are getting the contract, and then we are simply deploying. Once the transaction is successful, we are simply updating and storing in the local storage. Simple. So this is our deploy contract internal function. So we are done with the create token function. Now we have to build other function we have here. So let's build the writing function first. So first let's start with the create ICO, then we're going to build the get all user token and get all ICO token. That's all ICO. Okay, so let's start with the create ICO cell, and it's going to have the similar structure. So it's going to receive couple of things. So it will receive the ICO cell and it will come as a form of object. So we can come back here, we'll take this and we have to deconstruct this. So we'll have the address, we'll have the price, and it's coming from the cell ICO cell, because user has to provide the address of the token and the price which they want to create an ICO in our ICO contract. Once we have that, so we have to check whether this data is available or not. So we'll say if address is not exist and the price is not exist, then we have to simply throw the error message. The same thing we have to do. We'll take this notify error and we'll say data is missing. After that, we can simply continue ahead. So we can already build the functionality. So we'll build the loader to true, and we can notify the success. We'll say creating ICO cell. After that, we have to simply call this connect wallet function, and after that we can simply call the contract. So we can come here and we can take a variable contract, await, and we have to call our contract ICO Marketplace contract. Once we have the contract, we have to simply call the method, the function we have built. So we'll take this const payable amount and we have to simply convert the amount which we're going to pass into our function. So we'll take this ether utils parse units, and then we can simply pass this price to string and we can call it ether. So it will convert the price. Once we have the converted price, now we can simply build the transaction. So we'll take this transaction, await contract, and we have to call our function. So let's come back here in the contract, and here we have this particular function. So we can come back here, and this is the function we have built, created ICO cell. In that we are passing two things, token address and the price. So simply copy that one and paste here, and let's pass the data. So we have to pass the address and the price, the formatted price, and we have to also pass the gas limit which we are willing to pay for performing this transaction. So I'll go with this limit like ether.utils, and I want to pay in hexe, and I want to set this particular price like 8,000. It's in the way. Okay, this much money I'm going to pay for performing this transaction. I know it's pretty high, but you have to always check, you have to always do the testing, but I'm going with the highest range. Now I have to wait for the transaction to be completed. So we'll say wait. Once the transaction is completed, I have to simply, so once the transaction is completed, so I have to check if transaction dot hash means it exists, then the transaction is successful, and we have to simply set the loader off, and we can close our pop-up component. So we'll say set open created ICO to false, and we can set the recall to recall plus 1, and we have to notify the message. So it looks good, and I'm getting some sort of error. Let's see what is happening. Okay, I'm given this comma, but I have to give this, remove this one, give a comma. Now it will fix the issue. Looks good. We are simply updating all of that, and that's the only thing we have to do. And now we can simply do the same thing with the error if anything goes wrong, and we can simply close the component and we can display the error message. So we'll say something went wrong and let it be like this. So that's the only thing we have to do. First we are getting the object and we are deconstructing that and checking for the data is available or not. Then we can simply initializing the state, calling the contract and passing the data to our functions and checking for a state. If everything is okay, then we are simply continuing ahead. Simple logic. So this is our create ICO cell function. Now we have to work on our buy function. So let's open this one. What we can do is going to have the similar structure. We have to receive the token address and token quantity. So these are the two things we're going to take it from the user and we're going to pass into the function. So we can come here, we have to check the loader true, then we have to notify them that the transaction is happening. So we'll say purchasing token. Then we can take this variable called address and we have to call our function connect wallet. Connect wallet. So we got the address. Now we have to get the contract. So we'll say await ICO marketplace contract. Once we have the contract, now we can simply come here. So once we have our contract, now we have to check the balance of the token, whether the token is available in our ICO contract or not. If it's available, then only we allow them to purchase. So let's build that logic. So we'll say token balance, we'll say await contract, and we already have a function in our contract to check the token balance. So come back here, and if you come here we have the function called get balance. In that we have to pass the address and it's going to return the balance. So come back here, call it, and we have to pass the token address. So in this way we can able to know that how much token is available. So once we have the balance, and now we have to get the token details. So we can call it token details, and we already have a function to get the token details. So we'll say contract get token details. So we can come here, and here we have the function call it get token details. We have to pass the address and it will return the entire detail, and call it pass the token address. So we got the token address and token details. Now we have to build the logic. So we'll take this const and call it available token, so that how much token is available. We'll take this ether utils and we have to format that. So we'll take the token balance to string and looks good. So there we have formatted our token available. Now we can come back here, and here we have to build a if statement. So we'll say like available token has to be greater than 0. If it's 0, then we have to simply stop the transaction. Okay, it's obvious. If there is a token available, then only we want to make the transaction, otherwise we don't want to make the transaction. And let's build the logic. So once we have that, now we can take the price and we have to simply convert the price. We'll take this ether utils format ether, and we can in that we can pass the token price which we have in the token details, and we have to simply pass this string, and we have to simply multiply with the quantity which user wants to purchase. So in that way we'll get the exact amount, that how much user want to spend for buying how many token. So we got the price. Now we can come back here and we can build this pay amount, and we can convert this amount, we can pass into the contract. Okay, so let's call this utils parse units. In that we can say price to string, and it will be an ether. Got it? Ether, not ethers. So we got our pay amount. Now we have to make the transaction. So we can come here, call transaction await contract buy token. We got the address. Now we have to pass the quantity which user want to purchase. So we'll take this number, and then we can pass the token quantity which user want to purchase. And here we have to send the gas limit and the value. So we'll take this, we'll say value is going to be the pay amount. We have to make it in string, and we have to set the gas limit ether.utils, and this is the general convention I'm following. Okay, and that's the only thing we have to do. Now we have to wait for the transaction to be complete. So we'll say await transaction.wait. Once the transaction is successful, we have to simply update the state. So we'll check the loader false. We can simply call this recall +1, and we'll set this component to false, and we can also display the notification message. So we'll say notification success, transaction completed successfully. And that's the only thing we have to do. I can come back here and let's write the else statement, and we can throw the error message like false, component will false, and we can say the token balance is, your token balance is 0. And I can also display the error message. Simply copy this one and paste here, and it's going to change this to something went wrong, because this time there is a problem in the chain, not in the token balance. And this looks good, and that's the entire function we have for buying the token. So first we are changing the state, then calling this function for getting the contract, then we are checking the balance and the details of the token, then we are checking the whether the token is available or not. If it's available, then we have to simply convert it and get the exact amount which we're going to charge the user for buying the token, and that's what we are passing in our token contract. And at the end we are changing the state based on the success or failure. Looks good. So this is the entire function. Now we can write the next function called transfer token. It's going to be a quite similar one, and it's going to receive few data. So it will receive the transfer token data, and it will be an object. So we can deconstruct that, or we can use it straight away. So let's use it straight away. So we'll take this if, we'll take this transfer token data, and that will have all the details. The address, we'll say if the transfer data, if the address is not there, so let's make it not there, and transfer token data amount is not there, and the token address is not there, then we have to fail the transaction, because these three details we need: where the user want to transfer, what quantity he wants to transfer, and which token he wants to transfer. So those are the three check we have to do. If any one of these are missing, then we have to simply throw the error message. So we'll take this return notify error data is missing. Simple logic, building this state. Now we can come back here, and we have to set the loader to true, define the notification success, transaction is processing. Once we have that, now we can simply get the address through our connect wallet function. Once we have that, now we have to get the contract. We'll say await ICO Marketplace contract. So we'll have the contract. Once we have the contract, now we can simply transfer the token. So we can take this, we'll call it available balance ether.utils format ether. In that I have to pass the balance. So let's come here, let's come above, and we have to get the balance, then we can able to pass it. Okay, so simply replicate it, and this change this to available token, and simply copy, remove this one, and call our contract. In that we have the function called get await contract dot get balance of, parsing the address of the user. So in that way we can able to check the token which user wants to transfer, he has the fund or not. So that's how we are checking. So once we get the balance, we have to simply pass it here, available token, available balance, we have to convert it to a string. So we'll get the balance. Let's change this to available, available. So we got the balance. Now we can come back here and we can build the if statement. We'll check this available token should be greater than 1. Then we have to continue the transaction. So we'll take this pay amount and we have to convert it in way. So we'll take this parse unit and we can pass the amount ethers. So we got the converted amount and will be ether. So here we got the pay amount. Now we can build the transaction object. So we'll say await contract dot transfer. This is the function we have. In that we have to simply pass the detail. So we'll pass the, let's say, address and amount, and then we have to set the gas limit. It would be this one, maximum one, and we have to wait for the transaction to be completed with transaction dot wait, and after that we have to simply update the state. So it will be false. Just call this recall 1, and we have to close our pop-up component. This is transfer token to false, and we can display our success message, transaction completed successfully. So these are the state, and let's take the else statement, and we can say simply copy this one and paste here, and we can change this notification error. Everything would be fine. Let's change this error message only, and we'll say your balance is 0. Simply copy and paste here, and here we have to say something went wrong. Something went wrong. Very simple. Simple logic. We are taking our contract, checking the balance, and then we are allowing them to transfer the funds. So we are taking these details, initializing the states, getting the contract and the balance, and then performing the transaction. Looks good. Now we can work on our withdraw function. In that, we're going to take this withdraw quantity, that how much quantity user wants to withdraw. So we can come back here, we can check if withdraw quantity amount is not there, or withdraw token, because these two details we need, because our contract is an ICO contract. There is a multiple tokens are there, so we have to pass the quantity and the token address which we want to withdraw. So we have to throw the error message if it's any one of these two datas are missing. We'll say notify error, data is missing. Now we have to build the same logic. So first we have to set the loader to true, then we have to display the notification success message, transaction is processing. Then we can simply come here and build the address, connect wallet. Then we have to build the contract, await ICO marketplace contract. Once we have that, now we can quickly come here, take a variable called pay amount, and we have to simply convert this utils parse unit. We can pass the amount string, and it will be ether. Then we can take this transaction await, and we have the function called withdraw token, and that we are passing the token address and the amount. So simply copy this one and paste here. Let's pass the address of the token and the converted amount, pay amount, and we have to set the gas fee. So gas limit is going to be utils hexify hex, and this is the max size I'm giving. I'm going with this gas limit. Okay, so we are done with this. Now we have to wait for the transaction to be complete. Transaction.wait, and we have to simply initialize the state. So we'll say state loader false, component is going to be recall +1, and we have to simply false our component, means have to close our withdraw token component false, and we can display the notification success. We'll say transaction completed successfully. Simply copy and paste here, and we have to throw this error if anything goes wrong. Let's call it something went wrong, and everything would be fine. So this is our withdraw token function. Things are looking good. We have no issues so far. Everything's good. This is good. And here we have to export our context. So we can come back here. Let's call this export use state context, and we're going to use our context. So we'll take this use context, and then we can pass the state context which we have built on top here. This is the general setup we have to follow. Everything is looking good. This is the withdraw function we have, and this is the transfer token, buy, create, and these two functions are left, which is a very simple one. It will allow us to fetch the information from our contract so we can display it in our front end. So let's start with the very first one. Let's start with this. I can come back here. Let's initialize the loader to true. Then we have to get our address to check whether the user is connected with the wallet or not. We'll say connect wallet. Then we have to get the contract, await token contract ICO. We'll have the contract object. Now we can simply call the method. So we'll check if address exists, then we want to call it. Otherwise we don't want to call it. If we call it without address, it's going to throw an error. So we'll take this all ICO sell token, await contract, and we have the function. Let's call it get all token. This will give all the token which user will list in our contract for an ICO. Now we have to simply format the data. So it will have in a raw form. We have to format the data in a proper way so we can display in our component. So let's come here. Let's call this token array, and we're going to use this promise.all. promise.all is going to be an async. This is just a simple JavaScript. Okay, I'm giving the array and I'm calling this map. It's going to be an async, and we'll take the token, and here we have to simply format the data. So let's do that. So first I'm going to take this token contract, and we have this already. We'll say await token contract, and that we have to simply pass the token address. We'll say this token dot token, which is the address. If you look at our contract, this is what we have given, and when we pass this data, it's going to give us all the details about the token. So now we can use that. So we can come here, let's take a variable balance await token contract dot balance of. In that we can pass the address of the ICO contract, because we have to check that how much token is available in that ICO contract for that specific token. So we'll pass the ICO contract address. Once we have the token details, once we have the balance of that particular token in our ICO contract, once we're done with that, now we can simply return that data. So let's take this, and first we have to take this creator. It would be token.creator, and this data is coming from our pre-sale contract. Hope you guys haven't forgot the contract part. Then we can come here, we'll take the token.token, then we can take the name, token.name, then we can take the symbol, token.symbol, then we can supported, it's coming from token supported. After that we can take this price coming from same token, so we have to convert that. We'll take this ether utils format ether, and in that we can pass the token price. Let's call this token price. Now we can simply come here, we can call this ICO cell balance ether utils format ether, we'll say balance to string, and that's the data we want to return. So far things are good, and all we have to do is to simply return the data. First we have to turn off the loader. We'll say loader false, and at the end we have to simply return the entire array, and that is the only thing we have to do. I hope you guys have understood that what exactly we have done. We have got the address and the contract, then checking, and then we are simply returning all of this. So we are done with that. Now we can simply copy this one, and we have to simply paste here. So simply come here, and I have to simply copy this. So let's give this error message, notify error, and we'll say something went off if the transaction failed, or if the user is not connected, and try to call this function. So simply copy this entire try and catch, copy, and that's what we can paste here. And all we have to do is to simply change the method. So let's change this method name. Everything would be same. We have to change this method name. We can come here in the contract, and we have this function called get token created by. We have to pass the address of the creator. Copy, change here, and we have to pass the address, copy and paste here. In this way we can able to get the all the token created by single user, and that's the only thing you have to do. Let it be like this. No changes you have to do, just the function and passing the argument. That looks good. And finally we have completed our entire context management. I hope you guys have followed and understood all the logic we have implemented, that how everything is coming together. Everything is coming together, and things are look pretty good. So with that we are done with this particular session, and now we have to start working on our, in the next section we're going to connect the entire functionality we have built with our front end. So with that, let's move to the next video.